Hello. Today we're going to talk about food chains and food webs by Tim Bellicose and Duno Brogni. So, as we know, every organism needs to obtain energy in order to live. The primary source of energy for organisms is the sun. The sun is the base of energy at which life starts. It's also the key to survival for all species on Earth. The energy is transferred to plants, which then is eventually transferred to a variety of organisms through something called a food chain. So let's talk about these food chains. What is a food chain? Food chain would be a linear sequence of links in a food web starting from producer species such as grass or trees and ends at apex predator species such as grizzly bears or a killer whale. But then you have detritivores that feed on dead matter and feces, like earthworms or woodlice, or decomposer species such as fungi or bacteria. I'm not going to draw them, but it gives you an idea. So what this means is that a food chain is the sequence in which energy travels from one species to another via consumption. A simple food chain can start with grass, which is eaten by rabbits, and the rabbits are eaten by snakes. And then, on top of the food chain, the fox then would eat the snake. This would make it an apex predator species. It also doesn't have to just eat the snake. The rabbit could also be included in its diet, and other organisms, if it was the fox, as I said, will be at the top of the food chain, meaning that it is a tertiary consumer. The snake would be a secondary consumer. The producer would be at the bottom, which would be the grass, and the rabbit would be a primary consumer eating that grass. So as you can see, there can be 3 to 4 to 5 trophic levels on a food chain. It doesn't have to be set in stone. Doesn't have to be 3, it has to be 4, it doesn't have to be 5. So as I stated before, the most common trophic levels start with primary producers and primary consumers, then secondary consumers, and sometimes tertiary consumers. All these levels have a certain amount of energy that can be transferred to the next corresponding level. All the energy starts at the bottom with the producers, and then the energy is used up and passed on like this. 10% of the energy is consumed and passed on to the next trophic level. If a snake were then to eat the rabbit, it would receive 0.1% of the energy from the grass, and so on and so forth. So now, let's talk about a collection of food chains, which would be a food web. Let's talk about how that energy from in food chains is directly related to food webs. An exact definition for a food web would be the natural interconnection of food chains, and usually generally provides a graphical representation, usually an image, of what eats what in an ecological community. A more understandable definition of this would be that a food web is energy flow of organisms in an ecosystem. It pretty much overall just shows how the energy is passed around. Each food chain is one possible path that energy and nutrients may take as they move along through the ecosystem. Many consumers in a food web acquire energy from multiple organisms, just like us humans. They have more than one prey or just simply feed on producers. The producers' energies flow throughout the food web and are the basis for life in an ecosystem. A simple food web would start like this. Grass, trees, flowers, and other plant life will give their energy to different primary consumers. The primary consumers, say rabbits, squirrels, and trout or other fish, are eaten by secondary consumers, thus giving their energy to them. And the secondary consumers would be a wolf, hawk, and bear. And sometimes there can be tertiary consumers added into that. They are atop the food chain and usually never consume each other, although consumers in a food web sometimes have more than one food option. So the food technically starts around the sun. We didn't add it in there, but that's the basis of it all. So I think that about sums it up for our lesson today on food chains and food webs. Now please remember the difference between the two. Now thank you for watching today, and I hope you have a great scientific day.